this is Ladyada.
Hi, everybody, and happy Sunday, happy Purim to you. I'm at my desk. I've been working a lot on like tax reports because it's tax season, so like not as much harder as I would have liked, but I did get a little bit done. I thought I could just show off some of the samples and the testers I've been working on. So let's go straight into the overhead. So the first one is, if y'all remember a few weeks, maybe like a month ago, we did a design for the TCRT. Hold on. Focus. The reflective sensor. This was like the only through-hole right angle IR reflective sensor that DigiKey stocked, but it was like inexpensive. So I made a little breakout board for it with an adjustable emitter resistance, and then the signal level is analog. I mean, it's like digital, but it's analog because it's like, you know, if you're a little farther, it doesn't quite pull all the way to ground. It's ground when there's the light is reflected, and it's high when there's no light reflected. So let me just power this up. I'll show you the test. So as usual, I like to use my Metro 328 for testing. And I just have this basic stemma cable to test it. So test the connector. So you can see it's lit, and then as my finger gets closer, this LED turns on and it triggers, and then there you go. You can hear. You can see I really have to like get close, but that'll when this signal LED turns on, this detects that the signal is low and triggers. So good test. So this is good to go. I think, you know, I got this basically because I was going to do some like floppy disk index sensing, but it's also useful just in general when you want to do, because if you're using a like a disk, or you're trying to detect something spinning, these are very, very fast sensors, and white and black material will reflect a different amount, or silver. So you can use that to like do index sensing, or like a spinning thing, or like a wheel, or like rotation sensor, where you don't need a magnet. I don't want a magnet in my floppy drives. So that's one tester I got done. Really simple. This tester is a little bit more complicated. So this is for the LTC 4316. So this is a really cool device. It's an I2C address translator, and it will, you know, it's basically, it's a little annoying. You have to use two resistors to set the comparators to change like which bits you want to change. And it's like, I remember we did the math a couple of weeks or months ago, and it's like it's not trivial. Like, it's like you can't really use the potentiometer because it's a voltage divider, and the divider is like nonlinear. I also thought it'd be a little confusing if it's like you just tweak it until the value changes. So I did come up with like, okay, you can have two slide switches that change two bits, bits 4 and bits 5, and then bit 6 is always flipped, just because that's kind of the way the math worked out. And then you can also have another 4 bits that change by, you can't have like one resistor on the XOR low side, so you can change this resistor or short it to ground. You can get a couple more bits of changing values. So it's like, I couldn't, you know, like this chip can change all 7 bits of the I2C address, but like without making the board really enormous, and I couldn't use slide switches again. It just got very complicated and want to deal with it. So I was like, okay, well, you can have like 4 or 5 options. So the way I did this tester, you can go to the computer real fast, is oh, sorry, can you go back to the overhead real fast? I'll just show the. So on the tester, I have it connected. So there's an input and output side. So there's like the input I2C and the output I2C, where the address change happens. So I put a 24LC32 or whatever, like a I2C EEPROM on here, and those always have address 50 hex. And so you can determine, you know, as the address changes, you know that the address translator is working. So let me plug this in. I'll show the output. Yes, so go to the computer. So this one, let's see. Okay, so the way I test is I twiddle the bits on the XORL line and I verify that I get these 3 different addresses. So by doing like a light pull up or a if I set the using the internal pull up, that's like a 100K resistor, that sets the address to one thing. And then if I set the XORL to be high, that's another thing. And then if, you know, by default it's pulled low. And so that gets you 20. So remember it was 50, but then like the bits were flipped. So that basically kind of lets me test like all the functionality, including the enable pin. You have to toggle the enable pin in order to change the address. Like you can't just like change the resistance on the fly. It only samples that resistance at the beginning. So this is the low bits, which again, you know, I have a light pull down and then you can change it with an adjustable, and the high bits, which I have to, you know, set up this divider and then you can switch in or out 2 different resistors, 100K and 280K with this light switches. So these 2 testers are good. So these will be, you know, I'm actually trying to get a new pace going where I have 2 new products a week. So last week I did the Trinky SHT 41 and 45. I mean, they're very similar, but they are like 2 different products. Okay, and then how am I doing on time?
7 minutes.
Okay, great. I'll do a couple more minutes and then we'll do some samples and then we'll change over. So those are the testers I've been working on. So those were pretty straightforward. Oh, I did get a couple other cool samples in. So let's go to the overhead. So a couple other things I got. Okay, go to the overhead. Thanks. I got this QT BFF with the BNO 055 and a BMP 280. So this would be like barometric pressure, so altitude plus 3-axis location, like orientation. So, you know, just showing it on the back of the stem QT. And they also got the USB host BFF. So this is a Max 3421E. And I couldn't fit a USB-A port. I tried, but the USB-A port's actually like too big to fit here. So I just went with the micro B, and then you can use those like on-the-go cables. I also set it up for on-the-go, like the ID pin is grounded, I think. So it'll show up at, you know, you can use this directly with an on-the-go cable, and it'll give you a USB host. I haven't tested this. I just got this. And then if y'all remember a couple weeks ago, I also got this ultra precise temperature humidity sensor, the HDC 3020. So this came in also, so I'm excited to use this one, test it out. And I got the PWM generator, and like I totally got the math wrong. It's just like I was like either this is gonna work immediately out of the box or I totally screwed it up. I totally screwed it up. So I had it so that the minimum frequency was the same as the opposite, like the. So right here I was like, oh, it's up to 25K or up to 250 hertz, but actually I hold on. I got it the opposite way. So I made it so the minimum is 250, but it goes up to like infinite. So I have to go back and do the math again. 555s are like that. They're either trivial or like, you're like, how do I get this going? So I'll figure that out. And then I got some other samples. So some of the samples I got. Oh, well, yeah, I'm gonna. Oh, yeah. Hold on. Okay, so I got some key switches. I had a request for some key switches. So these are switches. There's electrical switches, but they use a key. I actually really like this one because it has the green and red to let you know whether it's connected or disconnected. So when it's red, when the key is, and this comes with a little a mounting hex nut too, which is like kind of nice. It doesn't come with a lock washer, but I don't know, you provide that. So get my multimeter going here. And then this is open, so like no beep. Open loop. Okay. And then if I close it, or sorry, if it's like green, then it's shorted. So like it's an electrical switch, but like it's a mechanical electrical switch with a little key on it, which I think is kind of neat. So this one has, I mean, like I wouldn't use this for like security, but like, you know, for just basic, like, oh, you know, maybe make it non-trivial to turn something on or off. I thought it would also be funny to make a keyboard. So like it would be a keyboard, but like it had like the QWERTY, all like whatever 50 keys would be keys. And the keys would have like the um character on it, and then you'd have to like go find it. So if you want to type a message, you had to like put one key at a time. Maybe. All right, so that's one key sample. So I really like that one. That one was pretty good. And then I also had, this is more of like a kryptonite lock style. So this one comes with wires on it, and it's a little bit heftier. This one doesn't have like the markings on it, but let me see if I can. Okay, it's like this, and then it's not as smooth, but it does work. I don't know. I mean, like, they're both kind of good. I think I like the key one more, but maybe I'll stock both in case there's some reason people want this. I mean, again, none of these are like secure. This one is nice because it does have the wires pre-soldered on. So that's that sample. And then, okay. Then I have these, I got this kind of cool toggle switch, which is also panel mount, but you need to have like a square cutout. And this one also has, yeah, this one has like has a blue LED. Hold on, there you go. It's hard to hold it. Yeah, it has a blue LED. The only thing that's a little bit weird about the switch is that the power goes into here, and then this is a normally open, normally closed. No, they're both normally open switches. And so when the switch goes on, it like switches the power in and out, which is like, okay, but it's like not how I would have, like the switch and the LED are not separated. They're like electrically connected. It's a little unusual. But I guess, you know, one nice thing is it's easy to wire it so that it's only lit when it's on, because you connect the power on the normally open side. And then when you close it, it puts the voltage across the two LED pins. So, I mean, I guess that's one nice thing. It's like less wiring, but you just have to make sure that the voltage you want to switch is the same voltage as the LED, which maybe is okay. It's like 12 to, I think it's like 12, yeah, 9 to 24 volts. So it's like a kind of a wide voltage. So this is not too bad. Kind of like the switching action on this. And then I also got similar, but this one does have separate LEDs, is this rotating switch. So let's see if I can activate this. So I kind of like, it's got this nice, it has nice like indicator LED, and then you can, this one, the indicator is separate from the switch. The switch is like totally electrically separated. So you see that there's two pins here for the LED, and then these are the mechanical switch, totally, again, not connected. I don't know, I kind of like it. I had the idea of getting these little items because we were looking at busy boards, like people who DIY busy boards for babies, and we're like, oh, because we wanted to build one maybe. And I was like, I saw like these kinds of switches, like, oh, those are kind of neat. I like that they have the LED in there. They're very satisfying. All right, how are we doing on time?
Up to 14 minutes.
Okay, great, perfect. All right, so that's what's on my desk. Not as many new designs, but you know, some samples that are coming in, and 2 testers. So you'll know it's going to be in the store in about like 2 weeks. Okay, let's go to the computer, and we're going to go to the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thanks, DigiKey. Every single week, Ladyada user power of engineering help you. Yes, you find the things you want on digikey.com. Ladyada, what are you looking for this week on digikey.com?
So one of the things I do is sometimes if I don't have a great search, like I quickly just look on social media and be like, what are people looking for on DigiKey? Or what did they find on DigiKey that's kind of neat? So this person, Toy Builder, we don't follow, but I should. They make all sorts of electronic projects, and this was kind of a neat one that they talked about. They're like, oh, this is a jumper cable that you know, you can solder in, or maybe you can even use with headers. That is ribbon cable with little crimps on it. And somebody was like, oh, where'd you get these? And they said, oh, I got them from DigiKey. And this like was like a total like flashback, because I used almost identical cables on the Zox box, like the first project that we worked on. one of the first products from Adafruit. Let me see if I can find it. Ribbon. Okay. It was which is slightly different. I mean, it's similar-ish. It's not flex cable. It's literally ribbon. And then it had these little like stripped-ish ends on it. And you could pull these off and solder them in. And basically there was 2 boards on the Zox box. There's the main board and the IO board. And maybe it was in the finishing section. Hold on. Okay, so you would cut these ribbons and solder them between the 2 boards, and it would connect all like the IO. And at the time, this made sense to me because we're like, oh, well, like you had 0.1-inch header, and then this way you could connect the 2 pieces easily. And we had to do all through hole. That was the thing. If it was surface mount, I would have used like FPC cables, but we were trying to do the whole thing only through hole, which is kind of nuts. So this was remember that ribbon cable. So I actually looked and I was like, well, is this even still sold at DigiKey? And the answer is it's called Molex WMO9. I went to the website and it was like, it is obsolete. So it's not in stock anymore. It was available like in every kind of length and configuration. But I was like, oh, well, maybe we could get these ribbon cables. Like, this person said, oh, I got these from DigiKey. If you do want to use something like this, let's find something similar. So since we don't want to get the ones that are not available, we'll do only active. And then we'll say normally stocking, just to get rid of it. So a lot of these are FPCs, which we don't want. We want this, right? Where it's like cables that have connectors so that we can look at the termination style. So when you say top and bottom with backers, that's definitely FPC. That's like a flex connector that goes into a contact with like little ears and you push them in. So you want the completely exposed wires on both sides. And those are, to solder in wires. And that'll get you a much smaller number of items. And you can see like, okay, these are looking right. I don't see the crimped ones. But let's say we want one with like, well, we want 2.54 millimeter, so 0.1 inch pitch spacing, and let's say 6 conductors, and then let's look at the lengths, let's say 3 or 4 inches long, which is pretty much all the connectors that we had on the Zox box were about this length and size. So this is what we've got. So there's no data sheet. Wait, this is a data sheet, maybe. Okay. So these are wire to wire. They don't really have a lot of documentation. They do have a whole family of these. So I'll say one thing, I've used them and they're very inexpensive. This is one of the reasons we use them on the Zox boxes. These are, it was basically the same price as having the individual wires. And it was like nice because they were ordered and like they had some flexibility and they, you didn't have to worry about like secondary connectors. The one thing I will say that was an issue with these to watch out for is that if you solder them in directly to your board, you do want to use hot glue where the connector touches the PCB because you're going to have this, whenever you have a flexing area and you have a stiff contact near the flex, and this is why you saw on the FPCs, they're like, oh, we have, stiffener on the back, is that's exactly that flex to rigid intersection, that joint, is exactly where you're going to get breakages because you're going to have something that's moving and something that refuses to move. And that's where you're going to get like the force that causes it to eventually crack. So we did have an issue where if folks were working on their Zoxbox a lot and they're moving a lot of pieces and they weren't, they went back and they did some work after the fact, they would crack and break the contacts because they were flexing it a bunch. These weren't really meant to flex a lot, but they are like, again, if you're using only through-hole processes or you want to like, you're reworking a board that already has 0.1 inch spacing, this is kind of like the thing to use. The only other alternative is you solder in pin headers, either right angle or straight, and then you use like socket connectors, but like those can actually get a little bit more expensive. I remember when we were pricing the Zox box, this was definitely the least expensive way to make those contacts. And again, if you do it as the last step, and there's not a lot of vibration, a lot of motion post installation, you're good to go. So this is my pick for the great search. Handy TE cables, not available from Molex anymore, but TE's got your back.
Where in the world is that part I need? The great search with DigiKey.
All right, and that's the show for tonight. We'll see everybody throughout the week. Thanks so much for joining us on this Sunday. That's Jessica Ladyada.
Thanks, everybody. Have a great day.